After the data sources, now we move to the Experiments module of WizeMLOps. This is where users can use the data sources configured in the previous module to create machine learning experiments and train different models. Let's quickly walk through the experiment creation workflow. The platform first allows us to select the required data source. Based on the selected experiment type, multiple machine learning models can then be trained and evaluated. The platform also provides several evaluation metrics, allowing users to determine how the trained models should be assessed. The experiment workflow additionally supports hyperparameter tuning and data visualization to provide users with greater control and visibility over the model training process. When we click Next, the first step is selecting the type of data source that will be used for the experiment. This could be a file-based data source, a database connection, or an external link, all of which we discussed in the previous section. For this demonstration, I will select a file-based data source and use it for our experiment. When I select the data source, the left side panel also provides access to the EDA information for that same dataset. This makes it easier for users to review and understand the selected data before continuing with the experiment configuration. Moving to the next step, we can see the different experiment types currently supported within WizeMLOps. These include binary classification, multi-class classification, regression, time series forecasting, image classification, text classification, and named entity recognition, or NER. If a user has a dataset but is unsure about which machine learning problem type should be selected, they can once again use AI Assist. The user can simply describe what they want to achieve using natural language. For example, I can enter a simple requirement stating that I want to predict the price of a house based on its available features. Once I click the AI Assist option, the system analyzes the requirement and automatically recommends an appropriate experiment type. In this example, because we are trying to predict a numerical house price, AI Assist recommends a regression experiment. The user still retains complete flexibility and can manually select a different experiment type if required. AI Assist is designed to provide guidance and simplify decision-making, rather than restricting the user's choices. After selecting the problem type, we proceed to the next page. Here, WizeMLOps displays the evaluation metrics that are relevant to the selected machine learning problem. Since we selected regression in the previous step, the evaluation metrics displayed here are specifically applicable to regression models. The user can select the preferred metric based on how they want to evaluate model performance. The next section provides hyperparameter tuning options. For users who are familiar with machine learning and want greater control over model training, WizeMLOps provides the flexibility to configure different hyperparameters. This allows more experienced users and data scientists to customize the training process according to their specific requirements, while users who prefer a simpler workflow can continue with the standard configuration. Several configuration options are available depending on the selected experiment type and model requirements. After configuring these settings, the next important step is selecting the target variable. As mentioned earlier, our example objective is to predict the price of a house. Therefore, the house price becomes our target variable, while the remaining relevant columns can potentially be used as input features. WizeMLOps provides multiple approaches for selecting these features. Users can manually choose individual features based on their understanding of the dataset, or they can select all available features at once. The platform also provides an AI-assisted feature selection option. By selecting this option, AI Assist analyzes the available dataset and recommends a set of features that may be suitable for predicting the selected target. As we can see here, AI Assist has generated a recommended list of features for this particular experiment. Once the features are finalized, we can proceed to the next step and provide an appropriate name for the experiment. For example, we can provide the required experiment name here, and then click Finish to initiate the experiment. As we can see, the model training process has now started. Once training is completed, the experiment results become available within this section, allowing users to review the overall performance of the trained models. The experiment results begin with an overview section. Here, users can view information such as the experiment status, selected target variable, best performing model, model type, data source used for training, and other important experiment details. The platform also provides visual representations of feature importance and model performance. These visualizations help users understand which features have contributed most strongly to the predictions and how effectively the models have performed. Further down, users can compare all the machine learning models that were trained as part of this experiment. The platform displays their respective performance scores along with the time taken by each model during the training process. So, this covers the primary workflow of the Experiments module, where users can take their configured data sources, select the required machine learning problem, train multiple models, and compare their performance. Another important capability available for Experiments is the AI report. While users can review the technical experiment results directly through the experiment dashboard, they can also generate a more readable and structured interpretation of those results. By selecting Show under the AI Report section, WizeMLOps presents the experiment information in a more human-readable report format. The generated report includes an analysis overview, summary statistics, categorical feature analysis, correlation analysis, and model performance information. Towards the end of the report, users can also review AI-generated insights and recommendations. This provides a report-style representation of the experiment and helps both technical and business users better understand the outcome of the machine learning analysis. Thank you for watching.